Hello, this is Peter Bartholomew. Today I'll take a further look at recent developments in Excel 365. In particular, I will consider the use of Lambda functions to access complex multidimensional data sets. The problem I'll use is based on a challenge outlined by Bill Jelen in his Netcast 2316. The key element is that the data is repeated in an array across the sheet and a more complicated structure down the table. What starts as a fairly simple table of deployment of a single employee along the timeline against various categories of spend becomes more sort of complicated as additional employees are added and different categories of data, here US dollars and hours. Now, the data analysis community will point out that the original data is held in an unsuitable format. A pivot table normalized format would be far more suitable, and the analysis would be fed through the pivot table. That's fine for data that's coming from a computer source, another app, but for manual input, it presents problems. That's each record contains additional typing over and above the number you want to put in. And it's not immediately obvious that there are typing errors here and duplicate records and missing data. That's the format is not particularly readable. So what I'd like to do instead is to go back to the original data sets laid out as convenient for the user and to try to use that directly. What I plan to do is develop a Lambda function here called DATAlambda, which accesses the data as a four-dimensional array with 4 parameters. The first parameter addresses the category of spend, here client A. The second parameter runs across and picks out a particular horizontal block, here for the employee. Then that narrows the data down to a 2x4 block, and the final parameters to pick out a value are the units, whether we're talking hours or money, and the quarter. And that will return a value. Turning now to the development of the Lambda function, I dedicate a sheet in my workbook for the purpose, and looking at the functions I wish to use, you see that it's actually quite a complicated construction. I've got nested Lambda functions and 2 sets of parameters. So rather than starting there, just for a moment, I will divert and look at a slightly simpler function, which I've also used in the workbook. That sums the columns of an array. So if we look at the formula, it's a Lambda function, and it takes an array as here's the dummy parameter. The actual parameters I put in are just a little 2x2 constant array. And the function tests the number of rows. It checks whether the contents are numbers or not, put 0 for non-numeric data, and then constructs an array to multiply using mmult, and that will give a total. This is a working function, but it's an anonymous function. If I look at what happens when I don't have the parameter on it, you get an error from the Lambda function and a very unhelpful message which says you can't define a Lambda function in a cell, go to name manager to do it. Well, like hell, I'm going to name manager to do it. That's an awful environment for developing formulas. So what I do is I develop the formula as an anonymous Lambda function, which at least gets me something working. I then also specify the name that I want to use and the comments I wish to upload. And I've got a VBA macro which uploads the function to a name column, so goes into column total, upload, and now the function here is a working function. To apply the function, I can switch back to the pivot table example and take a look at the data held in the pivot table. And if I just type equals column total, select the data, and there you see the Lambda function working, producing the correct set of totals. Returning to the development sheet and going back to the functions I'm interested in, this function is two Lambda functions, and the first one will run from there down to the beginning of the argument list. And if I upload that, then you see that to the name arrayref, then my function DATAlambda has come to life, because DATAlambda is defined in terms of arrayref. What I'm doing with this is, by splitting the parameters into two blocks, is that the recurrent data, the array that I'm referencing, and the vertical and horizontal stride lengths are used in the definition of the function DATAlambda, so that I've specialized the arrayref to address a particular array. This means that in use, you only need to specify the indices. It is DATAlambda that is used. Turning back to the problem sheet, I have now defined a function, this DATAlambda, which separates out the challenges of accessing data from those of using it. So I can either have this single element returns through here a set of spinners and just changing the values to scan the array, or I can use it in a more complicated way to solve Bill Gillen's original problem. That here you can see the DATAlambda is category index, employer index. What these indices are is equals category index. So 1 to 6, 1 to 6, 1 to 6. Employee index. A whole block of ones, a block of twos. These are calculated by using mod functions and quotient functions. And of course the quarters just runs across. And if I use those within the data lambda function, then I get the entire array. And if I took that formula, put it over here, say, and then put row total. So I put another lambda function wrapping it. I get the totals for the year, say perfectly correctly, and say without actually having to face the complications of accessing data directly from the original source. I hope that's been informative, and until next time, goodbye.